Welcome back to the channel. Let's look at the further problem statement. Reshape matrix. Write a Python function that reshapes a given matrix into a specified shape. So uh, I have to tell you that a reshape matrix is actually a subset of what we are solving, but reshaping is used in many applications. It's probably used in every application in deep learning, and also sometimes in machine learning. You have to reshape it no matter what the input data, either it's a sensor data or either it is whatever, right? Whatever the data that you have to reshape it into a specified form, represent it for the neural network architecture to understand or learn patterns from this type of representation, right? So this is a keyword, representation, right? How do you represent an input efficiently? That is very important. Okay, and one of the best application, or from one of the greatest application of that time is image classification. From an image that you have to classify what type of class label that is, right? I think probably before 2010, I think from this application NVIDIA has been developed their core GPUs. So let's look at that. Let's look at it in a perspective. You have a 2x2 matrix. You are actually solving how do you reshape only matrices, right? But in real world, or in and actually constructing your neural network architectures, you have to reshape any dimensional tensors. It can be 3, it can be 4, it can be 5. Sometimes you use batching, so it might be increased by 1. And for example, embeddings, and all these things, right? This is very important. Reshaping is very important, but in this particular problem statement, will concentrate only on reshaping matrices. So you have a 2x2 matrix. How can you reshape it? You can probably reshape it to 1x4, right? And you can reshape it to 4x1, right? You can reshape it to 4x1. So what pattern do you see? The number of elements or the elements are not changing, only the representation is changing. How do you represent this matrix? How do you represent this one? How do you represent this one? These three are matrices. How do you represent the values inside the given input? For example, in image classifications, we use grids or matrices, because image is actually a three-dimensional matrix, or a three-dimensional vector. So you have, let's say this is a black and white image. Black and white contains, it's two-dimensional, so you have a size of 28 cross 28. Okay, and you use convolutional operations, and you take the most important features out of it. And what is the output convoluted image looks like? 64 cross 7 cross 7. That is the amount of size that you have. Okay, 64 channels of 7 cross 7 images, 7 cross 7 matrices that you have. If you are trying to classify it, which means you have to probably use a neural network, and then you have to give the output nodes, 9 output neurons, and then probably use a cross entropy loss for this. This is how the architecture looks like. But you have to flatten it from this stage to this stage. In order for you to convert it, you probably have to flatten it. Okay, this flatten operation is nothing but, if you consider 64 cross 7 cross 7, you have 3 1 3 6. So the input layer, right, for this one is actually a single list of 3 1 3 6, and the output for this single list is 128, and then 128 to 10, and then 10 would give, and after that you use a softmax operation to give the weightage for each class, right? So this is how it is. So you have this matrix, let's say 7 by 7 or whatever. You will convert this matrix to this one. This is what reshaping a matrix looks like, right? But in real world, you probably have to reshape tensors with more dimensions. For example, in image classification case, you have to reshape I think 64 matrices, 64 7 cross 7 matrices. So that is a very big list, very big data, and you have to reshape it to a single dimensional vector, and this vector is actually used in neural networks or feed forward neural networks for this case. That is the problem statement, and that is applications that you see. We will try to implement this effectively. What another thing you have to see is number of elements don't change. Okay, so if the input the new shape should be equal to the current number of elements. So the number of elements in the reshaped matrix and the input matrix should be the same. So that is how we will check the first edge case. You say new shape of 0 into new shape of 1 is not equal to length of a to length of a plus as we are only considering reshaping matrices, so we don't have to probably look for any other conditions. For example, for multi-dimensional arrays, for let's say non-matrices, for tensors, this condition may not be useful, right? So we have to use probably like a dot shape or to effectively do that. So that's the edge case. The next thing is looking at this problem statement, we can probably use a sliding window technique, right? For example, I'll try to flatten this first, whatever the array is, and I can probably use a sliding window of size 2, and I can iterate for 4 times with the sliding window of size 2, 1 2 3 4 5 6 and 7 8. That is the output. So we can probably do that, but before that you have to kind of reshape. You have to flatten this out. How do you flatten it? You can go I is a list, and then J is an element. Okay, matrix contains all the matrix elements, so you can use matrix is equal to this, and for you have to iterate it for 4 times, which is new shape. Okay, for I in range shape of 0. So after that you need a pointer as a sliding window. I can say left pointer, something like this, and you have to slice this one, which is matrix of L to L plus new shape of 1, and you can try to append it. Okay, and you have to increment it, because sliding window you have to slide it, and is equal to L plus new shape of 1. I think that's it. Okay, 2 test cases and 1 hidden test. Okay, let's look at optimizing this code. I think this would take more time. It's a length of 8. I can do we should work for 1 cross 8 too. Yeah, let's look at the time. 37. This I think you can do something like j for j in this one and for I in this one. You can probably optimize this in one single line. Another optimization is you can use sum function, and then you can pass in an array to get all the elements in a single dimensional list. So this would give you the exact thing. Probably it's still 36 milliseconds. You can also try to optimize this one. I into okay. Oh, 1 second. Okay. It's I think there's a problem in indentation, so that is why. L plus new shape of 1. Okay. Oh, you are iterating through one time. You can probably say this one. So in this case, you're trying 1 cross 1, 2 cross 1, 3 cross 1, which is this one. 0 plus 1 cross 1, 1 plus 1 cross 1, 2 plus 1 cross 1, 3 plus 1, 4 plus 1, 6, 5 plus 1. Another kind of reshaping is what they do: 4, 2, 1 cross 2, which is this one, and 0 plus 1 cross 2, 1 plus 1 cross 2, 2 plus 1 cross 2, 3 plus 1 cross 2, which is this one. So you can probably say I into new shape of 0, 1. Yeah. You can say I plus 1 into this one. You can try removing this. Yeah, I think it's still the same. 4, 2. Okay. Another method, you have an internal method by using numpy array. You can convert this into an array by using you can convert the list into an array, and then you can pass in the 4, 2, something like this, right? It's now it's a bit high. It's 29 milliseconds. At first time we are getting milliseconds, and second time it uses catching and all these things, but if you consider that both use catching, it's still less, right? And if you still try to increase this one, right, which is 16, I can probably do 4, 4. Okay, and the same 4, 4, 28 milliseconds. It's still less. So when you increase the size, it's increase more, because you have to go through new each and every element, and then you have to do it. It's not very optimized. It's definitely not very optimized. You can see the torch implementation, which uses numpy. If you see this one, right? Yes, there is a reshape function, and which uses funcs.py, and this is how they use all the PyTorch tensors and everything, whatever the list that is there, and convert into numpy array, and then they use these numpy internal functions to compute it. Or you can also probably use numpy arrays to do that. You can also see the numpy code. What is the code thing? Let me know if you need a new video of what is an exact reshaping tensor video for optimized implementation. But you can also use, because it's taking less time, right? For example, n cross n, 16 cross 16, it would probably increase more. All right, it would go around millisecond, but this would be around milliseconds. If you see the help function dot np dot reshape, right, you can probably get all the methods that you have a new shape, and the order C, like for C is CFA, and then it's an optional function. What is, I think, indexed or reshaped array, read write elements in C order last. Okay, yes, and then you can there is also in PyTorch or TensorFlow, there is also view and reshape, and I think in TensorFlow also you have reshape functions. Exact name is reshape. In machine learning or deep learning, you would definitely use reshaping functions. Without that, you cannot do that. Even in computer vision, without that, you cannot do that. You have to the main thing is the deep learning right now, and whatever the algorithms are coming, right? So they have what's known as, they are also known as they are called in the subset of representation learning. Okay, how do you learn from the exact representations? If it's an image, okay, how do you learn features from an image, instead of creating statistical features and then using machine learning algorithms or statistical learning algorithms? So how do you actually do that? So that is a problem, right? So that is why CNNs has came up, AlexNet, and all these architectures, and then object detection algorithms. I think today YOLO has been gone to 11, I think 11 or 10, I'm not sure, but there is always versions that are newly coming up with vision transformers, which uses transformer architectures with integrated with image patches, right? So that is also one thing. So wherever you go, there is an reshaping you would use, but reshaping in this problem, it's an easy problem. So we are focusing only on reshaping matrix. We are not focusing much on reshaping tensors. Right. For reshaping tensors, you have to look into superset of problems. Okay, you doing like this won't work. You have to look into more optimizations. And if you probably solve that, you can probably solve this reshape matrix as well. So yeah, that is the thing. So that is one we'll be focusing. Let me know if you have any optimized solutions for this in the comments, and let me also know to recreate np.reshape function for any type of list or any type of multidimensional array. So yeah, thank you for now. That's it.